Now we're moving on to chapter 2. In this chapter, we'll be talking about limits and derivatives. Let's start off with limits. So before I describe what a limit is, let's first look at these three graphs. So if you notice, they're pretty similar to each other, except what is happening at x is equal to a. So for the first graph, when you get to x is a, you just have a y value that's L, right? Nothing weird is happening at that point. For the second graph, we have at a, something weird happen. So just imagine that you're going along this curve. So you're doing the exact same thing as you did in the first graph, but when you hit a, you're somewhere else. And then you just keep going along as before. And for this third final graph, at x is a, what's happening is that you go along and then you skip that point altogether, and then you just keep going on after that. So they all have different behaviors at x is a. Let's write down what the values of f of a are in each case. For the first case, f of a is just L. The y value is L when x is a. For the second case, f of a is not L, but it is M. The y value at that point is M. And for this final graph, f of a doesn't exist. There's a hole there. You're skipping that point. It is not in the domain. So f of a does not exist. I will often abbreviate this as DNE. Now, they do, however, have something in common, and that's the behavior near x is a. Right, so let's look at this first graph again. As you go towards x is a from the left and from the right, you're getting closer and closer to the y value of L. And for the second graph, as you get closer and closer towards x is a from the left side of the curve and from the right side of the curve, your y value is getting closer and closer to L again. And same idea for the third graph. As you get closer and closer towards x is a from the left and from the right, your y value is getting closer and closer towards L, this point. So we'll write that down. In all three cases, as x goes towards a from both sides of a, f of x goes towards L. As x goes to a, y goes to L. And we can write this using symbols as follows. We'll write LIM, which means a limit, and below this we'll write down what x is doing. Well, x is going towards a, so we'll write x goes towards a. And to the right of this, we're going to write down the function name. The function name is f of x. And we say that this is equal to L in this case. All this is saying is that as x gets closer and closer to a from both directions, the y value is getting closer and closer to L. And how you read that is as follows. The limit of f of x as x approaches a, or as x goes to a, is equal to L. This applies to all of these three cases. Even though the behavior at x is a is all different, this is true of all three graphs. So what that means is we don't care what's happening at a. At x is a, y value could be L, could be something else, or not defined at all. So to emphasize that, I have a remark here. In finding limits, we do not care about what's happening at x is a. We only care about what's happening really, really close to a. So in other words, how f is defined near a from both sides of a. All right, so let's try some limit questions. The first one is asking you to evaluate this limit. So this is asking you, as x gets closer and closer to 3 from both sides of 3 along the curve, what is this function getting closer and closer to? Well, let's first draw the graph of y is equal to 2. Now, x is equal to 3 on the curve is here. So you're approaching that point from the left side of the curve and from the right side of the curve. So as x gets closer and closer to 3 from both sides of the curve, y is 2. So that is your answer. In fact, this number could have been any other number, and the answer would always be 2 for this function, because y doesn't change. Y is always 2. Alright, so for the second one, we have a piecewise function, and we're going to do the same thing as before. We're going to draw this graph first, and then look at the graph to answer this limit question. We're first going to draw the graph of y is equal to -1 when x is negative, meaning to the left of the y-axis. That means we have something like this, and an open circle at x is 0, because x is 0 is not included here. And for the second line, we have y is equal to 1 if x is to the right of the y-axis, including the y-axis. So that means we have something like this, and a closed circle here, because it includes x is 0. Now this question is asking you what happens to the y value as x gets closer and closer to 0 from both sides of 0 along the curve. As you keep coming towards x is 0 from the left side of the curve, you're going towards -1. The y value is always -1. But if you're coming from the right side of the curve, your y value is always 1. So notice that you don't have the same y value coming from both sides. Coming from the left, you have -1. Coming from the right, you have 1. So let's write that down first. As we approach 0 from both sides of 0, the function value approaches different numbers. So in that case, we say that this limit does not exist. D&E for short. So in general, if you're going towards two different numbers as you're coming from the left and the right, you say that the limit doesn't exist. All right, let's try another one. Here's another piecewise function. So this one says y is equal to x plus 2 as long as x is not equal to 1. So let's draw that. Y is equal to x plus 2 is a line of slope 1 with y-intercept at 2. So it's gonna skip that point, but everywhere else is going to be a line of slope 1. All right, and when x is 1, we have y is 1. So it actually goes through this point. So let's see what this limit is equal to. So it's asking you what happens to the y value as x gets closer and closer to 1 from both sides of 1. So let's come from the left side of 1 first. When you're doing that, you're going this way, and you're getting closer and closer to y is equal to 3. How about when you're coming from the right side? So get closer and closer towards x is 1 along the curve, and you're getting closer and closer to 3 again. So that means your limit is equal to 3. As x goes to 1, y goes to 3. We don't care about this dot at all. So this dot could have been anywhere along this vertical line, just going up and down forever, and your answer would still be the same. Now, the limits that we looked at so far, we always came from both sides, but now we can extend our definition of limits so that we only come from one side. Let's look at the graph of this function, which I've already drawn for you here. So now let's first look at this limit. So remember what this means. It means x is going to get closer and closer to 0 from both sides of 0 along the curve, and you want to know what the y value is approaching as you do that. So let's come from the left side of 0 first. So you're going this way towards x is 0, and your y value is -1. So let's write that down. Y goes to -1 as x goes to 0 from the left side of 0. Now we do the same thing as you come from the right side. So as you get closer and closer to 0 from the right side of 0, you're going to 1. So what that means is that this limit doesn't exist. Remember, if you're going to two different values as you come from the left and the right, that means the limit doesn't exist. However, if we just consider coming from one side only, the limit would exist, right? If you're coming from the left, you're going towards -1. If you're coming from the right, you're going towards +1. So to indicate that as you come from the left side of 0, the y value is approaching -1, we're going to write the following. Limit as x goes to 0, and then we put a negative sign as a superscript, so that means you're coming from the left side of 0, of f of x is equal to -1. And to indicate that when you're coming from the right side of 0, the y value is approaching 1, we're going to do limit as x goes to 0 plus. So the plus means we're coming from the right, of f of x is equal to 1. So even though the two-sided limit doesn't exist, these are called one-sided limits, and they do exist. And just like before with the two-sided limits, we do not care about what's happening at A. At x is A, y is 1, but that doesn't matter. This dot could have been anywhere else, and these two would still be true. So just again, for limits, we never care about what's happening to x is equal to A, but only what is happening very, very close to x is A. All right, let's try this easy example. First one is asking you what's happening to the y value as x goes towards 2 from the left side of 2. So x is 2 is here, and you're coming from the left side of that, so that means we're going this way. Get closer and closer towards x is 2 from the left, and the y value is approaching 3. So that is your limit. Now let's come from the right side of 2. So as you get closer and closer and closer towards x is 2 from the right side, the y value is getting closer and closer to 1. So that is your limit. And for this one, remember, if there is no plus or minus sign, you're coming from both sides. Since if you're coming from the left side, you're going towards 3, and if you're coming from the right side, you're going towards 1, that limit does not exist. Remember, you have to go to the same number from both sides for the two-sided limit to exist. And for this one, we're going towards x is 5 from the left. So when we do that, we're going this way. And as you do that, the y value is getting closer and closer to 2. So that's your limit. And if you're coming from the right side of 5 along the curve, we're going this way. And the y value is getting closer and closer to 2 again. So that's your limit there. Since when you're coming from the left and from the right, you're approaching the same number 2, this two-sided limit exists, and it is also 2. If the one-sided limits are different, then the two-sided limit does not exist because you're coming towards different y value from the left and the right. However, if your one-sided limits are equal, like this one, then the two-sided limit exists and it is equal to that number. So let's fill this out. As x goes to A, f of x is equal to L if and only if limit as x goes to A minus of f of x is L, and it's also equal to the limit as x goes to A plus of f of x. And what this theorem is implying is that if these two limits are not the same, then the two-sided limit does not exist. So that's the remark below here. If the two one-sided limits are not equal, then the two-sided limit does not exist. All right, I've divided this section into two parts because it is a pretty long section. So please pause here and work on these homework questions from the textbook, and then we can finish up 2.2 in the next video.